Hello, my name is Harrison Badawi, and we're going to be doing our project on the physics behind glasses. So the way the eye works is that it gathers information much like a camera. So the way it works is light enters through the cornea, which is a dome-shaped window that covers the front of the eye, providing 2/3 of the eye's focusing power. That passes through the lens, which is a transparent body behind the iris. It bends light when it enters the eye, and that passes through what's called the focal length, which is just the distance between the retina and the lens, and that's about 22 millimeters long. And after that data is sent to the optic nerve, which gets transferred to the brain. And the way glasses get put into context is that they change the focal length based on if you're nearsighted or farsighted, elongating or shortening the distance that you can see, allowing it to be clearer. Yeah.
All right, so as you heard from Harrison, glasses use refraction to change the focal length. So refraction is when the light bends due to a change in medium. Now this medium in this case is between air and glass of the glasses. So light bends, like the best way to describe it or compare it to something would be, imagine a car traveling down a road and it hits some mud. Now the wheel that hits the mud first is going to slow down and change the direction of the car. The light works in the same way. So here's an example of refraction in real life. You can see a person looking into water and they see a fish right here. This is their perceived location of the fish. As we see the light ray, then the natural perception would be to see a light ray continuing straight, but in reality the water is a higher index of refraction, so it's going to slow it down, and the actual location of the fish is down here. Are either used for nearsightedness, which is a condition called myopia, or for farsightedness, which is hyperopia.
So, when making glasses, it's all about changing the focal length and the point of focus so that the image will go directly to the retina. Light that passes through a lens is always bent towards the thicker part. So for a minus lens right here, the light is going to bend towards the thicker part, which is the outsides of the lens. And the thinnest part will be in the middle. This causes the light to spread out and the focal point to move back in towards the retina. For a plus lens, which is used to fix hyperopia, the base is in the center of the lens, the thickest part. So it'll move the focal point to the right. To put what I said into more simpler terms, we have this diagram where it's the same thing as a minus lens. Instead, they're triangles. So the light will enter the triangle, and because the triangle has a different index of refraction, it's going to bend it, and it'll bend it when it enters and bend it when it exits. So it'll end up going wider, and it'll push the focal point closer to the retina. This is for a minus lens. For a plus lens, you just flip the triangle so where when it enters, the change of index refraction will cause it to bend towards the bottom and meet in the middle, which is further away for the retina, which would be to cause farsightedness.
Was good. Thank you for watching our video.